Hey team, today we're going to take a look at drawing Bohr diagrams and Lewis structures for a variety of elements on our periodic table. So our worksheet lays out boron, but I wanted to go through it and maybe one extra, maybe chlorine, just to take a look and make sure we know what we're up to. I've copied and pasted those two elements from our periodic table. This looks exactly the same layout as what you would see on the yellow one I gave you yesterday. So to start, we are being asked to fill in some information for each element from our periodic table. So we're going to be filling in our atomic number, which remember is this number here. The name of an element, its atomic mass, which we find below the name on our periodic table. So just some fill in the blanks from our periodic table to start. Then we are asked to determine the number of protons, neutrons, and electrons. Note that we've used these kinds of notations for these particles to start, but they've got something different going on. So our first ask here is to determine the number of protons, neutrons, electrons. All right, protons are equal to the atomic number. So we're gonna have 5 protons from boron. Now, protons are positive, so we have 5 positives in the center of our atom. We need to cancel that out with 5 negatives. Electrons are negative, so we are always going to have the same number of electrons as we have protons. And again, that's to balance out the charge, bring it to neutral. To calculate the number of neutrons, it's not something that's immediately noted on our periodic table. We're going to calculate by using the atomic mass and our atomic number together. Remember, we are going to subtract from the atomic mass. We're going to subtract that atomic number. This is going to give us a decimal in this case. Oops, math and talking is hard. So 5.81, which we would round to 6. All right, from here, we need to draw our diagram. Our Bohr diagrams are the electron levels. And I like to just put the symbol of the element in the middle. And then we're going to draw a circle. Okay. Now remember, we kind of mentioned it earlier that the number of electrons in levels, in the first level, we can have 2 electrons. In our second level, we can have 8 electrons. And in our third level, we can also have 8 electrons. So the first level, only 2 fit. All right, and we are going to pair them up. So 1, 2 in the first level. All right, so that one is full. We can't fit anything else in the first level. It's a little smaller. So then we're going to draw another level, so another circle around. And in that level, I can fit up to 8 electrons. Wonderful. I only have 5 that I need to put in. We've already taken care of 2. So I need to put 3 more electrons in. Now, when you are filling any other level beyond that first one, we're going to go around in kind of a compass. So we're going to go 1 electron, 2 electron, 3 electron. This is most correct. It would be incorrect to pair them up here initially and then put 1 over here. That's not correct. We spread them out. All right. So this is our Bohr diagram. We can double check that we have 5 electrons. 1, 2, 3, 4, 5. We've put our symbol in the middle. Good to go. Some Bohr diagrams put the number of protons in the middle and the number of neutrons in the middle instead of the symbol, but it's an either or for me. I prefer the symbol. Okay. Now, the outer level is called the valence shell. All right, and the valence shell is the one that's most important and what causes elements to join up and make compounds. So we most often just want to know what's in the valence shell, and that can be represented by a Lewis structure. So a Lewis structure is just taking that valence shell, the outermost one, and drawing what you see without a circle around it. So I'm going to pretend that I have like the compass around my symbol, all right? And I'm going to add those electrons in just like I did before. I had 1, 2, 3. So you can see that what I've done here is exactly the same as what we had in this case. All right, now, if we are looking at chlorine, Chlorine has 17 protons. It's going to also have 17 electrons because they're always equal. And to calculate the number of neutrons, we're going to take 35.45, our atomic mass, and subtract the number of protons. This is going to give us, if my math is good today, 18.45, which we round down to 18 neutrons. Okay, to get our Bohr diagram though, all I really need is the number of electrons. I'm going to run out of room, so I'm going to quickly just erase what I've done over here. Okay, so our symbol goes in the middle, C, big C, little l, and we need 17 electrons. Remember that first level? We can just put those first two in together. Amazing. That's 2 electrons. Let's keep going. We need to get to 17. So 2, 3, 4, 5, 6. Once I get one time around my compass, that's only half of the 8 I can fit here. I've got 6 electrons total. I'm going to go back and double up. 7, 8, 9, 10 electrons. I'm still not good. I need 17. I'm at 10. Let's hold that thought. So we add another level. 10, 11, 12, 13, 14, 15, 16, 17. So that gives us our total number of electrons. Again, we can double check our counting if we feel we need to, but we should be at 17 electrons total, 17 dots. All right, to draw the Lewis dot diagram, we take the valence shell, the outermost one, we count the number of electrons. I've got 1, 2, 3, 4, 5, 6, 7. I'm going to put them in that exact same arrangement. So around chlorine, I don't draw any circles. I forget about those other levels that are full, and I'm just going to add my pairs and that one lone valence electron. So the difference between Bohr and Lewis is we don't represent all of our electrons in our Lewis diagram, just the outer level. But the outer level looks exactly the same on each. Good luck.